Good morning, students. There is a great saying by a scientist named Stephen Hawking: look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious. So, very curious young school student sitting under a tree and reading a science book saw an apple falling suddenly from the tree. Immediately, he started making some relevant inquiries, and being inquisitive, he made some relevant questions like, why does the apple fall on the earth from a tree? Can apple attract the earth? Immediately, the answer came in his mind that because the earth attracts the apple towards it, that is why the apple is falling. And can the apple also attract the earth? He says yes. It also attracts the earth as per Newton's third law, which he has discovered like that every action has an equal and opposite reaction, but the mass of the earth is much larger than the apple's mass, thus the force applied by the apple appears negligible and the earth never moves toward it. Similarly, a student was asking why the apple is not falling towards why the earth is not falling towards the apple, because the apple has lesser mass as compared to the earth. That is why, because the mass of the earth is much larger than the apple's mass, thus the force applied by the apple appears negligible and the earth never moves towards it. Even the Newton thus suggested that all the objects in the universe attracts each other. So this young student, that is Newton, Sir Isaac Newton, discovered the famous law that is named as the Newton's law of gravitation or the universal law of gravitation, in which he said that every body in the universe, it may be a particle or a body, attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Suppose we consider this red body and an orange body. It has a mass m1 and a mass m2. They are applying a force, attractive force between the to each other. In this way, the m1 body is applying a force F and even the m2 body is applying the same force F, because they have a force of attraction between each other according to the Newton. So they are separated by a distance r. So in this case, according to the definition of the Newton, he says that the force is directly proportional to the m1 and it is also directly proportional to the m2 and it is inversely proportional to the square of the distance between them, that is r. And from the above equation we can rewrite them as following, that F is directly proportional to m1 m2 upon r square. And if we remove the proportional sign, a universal gravitational constant is being added in it, that is the F is equal to g m1 m2 upon r square. This is the relation for the Newton's law of gravitation, that is universal law of gravitation. It is a universal equation for an attractive force between two bodies, that is the F is equal to g m1 m2 upon r square. Now, what actually the universal gravitation constant is, that is g, and what is the unit? So if we understand that, if we take the formula that is F is equal to g m1 m2 upon r square, and if we transfer the r square to the left hand side, the formula comes out to be as g is equal to f r square upon m1 upon m2. And if the masses are 1 kg, if we consider the masses 1 kg and the distance between both the masses, that is 1 meter, the gravitational constant will come out to be equal to the gravitational force. So the definition of the universal gravitation constant can be in such a way that the g is equal to the gravitational force, which is F, which acts between the two bodies of masses 1 kg, each separated from each other by a distance of 1 meter. That is, a universal gravitation constant is equal to the gravitational force if the masses are 1 unit and separated by a unit distance. And the value for g is, that is 6.673 into 10 to the minus 11 Newton meter square kg per kg square, and it was found by Henry Cavendish by a famous experiment. And according to the different notation, different units of the force, distance and the masses, the unit for universal gravitation constant will come out to be as F is Newton and R is meter square and m is kg into kg. The unit will come out to be as Newton meter square per kg square. So in this way, students, we understand the importance of the universal law of gravitation. Actually, it is called the universal law of gravitation because it is acceptable universally. It can act between any two bodies universally, whether they may be a smaller body or a bigger body, if it may be a celestial body or any body. It acts everywhere in the entire universe. That is why it is named as the universal law of gravitation, and it has many significances. Like, if we consider the tides in our oceans, the motion of the planets around the sun, the flow of water in the rivers, for rainfall and snowfall, all happens because of the action of the gravitational force on the different objects, different regions of the celestial bodies and different celestial bodies. So students, I think you were able to understand this basic concept of Newton's law of gravitation. It's very important for your exam point of view. So please properly learn the derivation and solve the numericals based on it, which I'm going to teach you further. So this universal law of gravitation was derived with the help of the Kepler's law, which I'm going to explain in the next class. Thank you, students.